Exactly 12 years ago in a TEDx talk, I've introduced my 7 species of robot. A unique 3-leg robot called Strider, a wheel-leg hybrid robot called Impasse, an amoeba robot, and many more. Now, 12 years is a pretty long time, especially in a cutting-edge field like robotics. How have our robots evolved during the past 12 years? What new species of robot have we built since then? Hello, my name is Dennis Hong, and today I would like to show you our next 7 species of robot. Since my last TEDx talk, we've been focusing on the development of humanoid robots, robots that look like us, 2 legs, torso, 2 arms, and a head. Let me show you some of the humanoid robots that we developed at our lab, Romela. Darwin is a miniature humanoid robot for research and education that we made it fully open source. Charlie is considered the United States' very first full-size humanoid robot. Thor RD is for disaster relief applications, and shipboard autonomous firefighting robot Sapphire and Thor, which uses a unique biologically inspired actuator, and many more. I think we built more than a dozen different types of humanoid robots. However, after more than a decade of humanoid robotics research, I'm starting to have different thoughts. Now, humanoid robots are important and they're great. However, they always fall down. They're too unstable and they're painfully slow. Yes, these days we're trying to develop technology that resolve these 2 problems, but still, they are too expensive and they're too complicated. And most importantly, they're too dangerous. You do not want to be next to these big, heavy moving robots. It might fall on top of you. So what do? Now, why is it so difficult to make robots walk with 2 feet? I mean, we do it all the time. So once I wanted to throw away everything I know about robotics for a moment and try to think fundamentally, why is it so difficult to make robots walk with 2 feet? And I found something fascinating. So check this out. Now, when your robot tries to move forward, one of the reasons why it constantly falls down is because the distance between your left and right leg. Because your legs move forward and backward, up and down, it creates this unwanted twisting forces. We call this moments, right? Now, this is a video called a Robo 1 competition. It's a robot fighting competition. And people who participate in this competition are robot hobbyists. And if you look at the robots they developed, it's brilliant. It's fast, it's nimble, and it doesn't fall down. And if you look carefully, they always walk sideways. Because if you walk sideways, your left and right leg line up, so your twisting moments disappear. I actually got this inspiration by watching sports, fencing, or ballet. They always walk sideways, and I think this is the reason why. Now, one of the problems of trying to make robots move sideways is you cannot really use your knees. So what do? We rotate our legs. It looks kind of awkward, right? So actually, let's change the entire torso like this and make it walk this way. Now, the problem of this kind of configuration is that you really cannot use your feet and ankle. So what do? We get rid of them. Now, let's make more changes. Let's change the shin. And while doing that, let's change the head. And something strange starts to emerge. This is Nabi, Nonanthropic Biped. In other words, it's a robot with 2 legs, but it does not look like a human. How does it walk? It walks like this. Simple, fast, easy, low cost. Isn't this great? Now, I briefly mentioned about a robot called Sapphire, shipboard autonomous firefighting robot that we built. This is a robot for Navy ships. And I don't know if you've been on a Navy ship, but if you open this door, it has a really high door seals. We call that knee knockers. Before we had these robots, it was very difficult for the robot to climb over it. But if your robot does not have to be like human, we can do something like this. Make the knee rotate at 360 degrees. Brilliant. Isn't this cool? Yeah. Our robots can climb stairs, but it's rather difficult. But now we can climb stairs like this. Now, is this just simulation and animation? No. In 2 weeks, from the idea, analysis, design, and fabrication, in 2 weeks, we built our first robot, and you have not seen anything like this.
You're wild.
And we use many different types of tricks. For example, utilize the springiness of the feet. We can store the energy and make it hop and jump.
1.
When we first introduced Nabi to the community, it had a pretty good impact in the community. However, this robot is great for walking forward and backward. But how does it change directions? It can't. So we decided to work on the next version called Sapphire. Alfred. Alfred stands for Autonomous Leg Personal Helper. robot with enhanced dynamics. So think of this robot as two nabbies stacked onto each other. So it looks like this. So this robot is axisymmetric, which means that there's no forward, backwards, or sideways. Now, when it walks, it has a very wide stance, right? So it can walk like this, and this is great for unstructured outdoor environments. However, it's pretty slow. If you want to make it go really fast, you can change your body configuration. And if you go like this, you can have your forward legs and backward legs, and then you can gallop like a horse. There you go. And when you lift two of the arms, you can walk like Nabi. Then the two of the other legs can be used as arms to pick up boxes or press buttons. And we're pretty excited about this new type of configuration. We call this multimodal locomotion, and this is Alfred. Now, while developing these robots, we've been also working on this new type of actuator. Now, when we say actuators, we're talking about these devices that make the robots move, just like muscles in humans. Now, most of the robots that exist today, electric robots, use electric motors with gears, right? And these are really strong and they're precise. They're good for manufacturing. But for legs, we need something different. We need something like biological muscles that's compliant, springy, and not only the position, but also change the force. And we developed a new type of actuator called the Bear actuator. Now, using this Bear actuator with the Nabi, we developed a second version called Nabi 2. Now, if you remember, Nabi was our experiment for studying new type of bipedal locomotion. But it turns out that this Nabi with these new actuators doesn't work very well in terms of walking. However, unexpectedly, we didn't know this, but this robot is great for jumping and hopping. It can jump forward, backward, and turn directions. It's brilliant. But the really cool thing is, once it jumps and when it lands, the motors become generators, and the impact is changed to electricity, and it can charge its battery, so it's very energy efficient. And Nabi 2 is ready to go. Or not. But this is Nabi 2. So Bear actuator with Nabi was Nabi 2. Then Bear actuator with Alfred is Alfred 2. And this is the next generation of Alfred. So this is the very first time you turn on the switch. Look carefully the reaction of our students.
Oh my lord.
Excuse me.
Oh my god. Yo! Oh my. That was amazing.
I think it jumped about 1.4 meters. This is remarkable. Walking is also very fast and stable. So we wanted to do something more interesting. We wanted to make it do taekwondo.
Whoa! Shit!
We're just having too much fun. And Alfred 2 is ready to go. Now, Alfred 2 is actually a very practical robot. For example, this is an example of picking up a box, delivering it, and putting nicely on the ground or on the table. I sped up the video because it's pretty slow, but you can get an idea how we can use these new type of robots for different applications. And this is Alfred 2. Now, we looked at 2 legs. We looked at 4 legs. What about 6 legs? Of course, we have a Hexapod robot. Now, this robot Hex is about the size of a small car. Now, the cool thing about 6-leg robots is this. Now, to have static stability, the minimum number of contacts with the ground is 3. Think of a camera tripod. If you have a hexapod robot, you can always have 3-point contact with the ground, 3, 3, 3. And this makes it really great for outdoor environment, rough environment. This particular robot we're developing for demining applications, getting rid of landmines underground autonomously. If you see it in person, it's kind of scary. It's big and goes like this. So this is Hex. We also have a smaller version. This is called Sylvia, 6-leg vehicle with intelligent articulation. And as I mentioned, these type of robots are really great for unstructured terrain, such as this. You can also climb up and down stairs. And this robot might be the strongest 6-leg robots out there.
20 kilograms.
Now, the reason why we wanted to make it really strong is because we want this robot to do some very interesting new type of stuff. So this is the very first robot that can brace between walls and climb up. Just like Spider-Man. Isn't that cool? And it has some other tricks too. If you put suction cups on the feet, it can stick to the wall and climb. And if you give it an arm, it can do some fun stuff on the blackboard too. And this is Sylvia. So we talked about vertical mobility. 12 years ago in my last TEDx talk, I've introduced a robot called Climber. It's a robot for climbing cliffs using cables like a human. But this year, we want to get rid of the cable. We want to make it do free climbing. And I'm very excited to introduce a brand new robot called Scalar, spine-enhanced climbing autonomous leg exploration robot. Now, when you first look at it, it looks like a generic quadruped robot, 4-leg robot. It's actually very strong, but strength is not all. We had to develop this new type of gripper. We call these spine grippers that can really grab onto the surfaces. And this video, we just took it a few days ago. So literally, it's taking its very first few steps. Now, why are we interested in cliff climbing robots? Rescue missions, of course, but we're really interested in planetary applications. Now, as you know, in Mars, we have these rovers discovering the new planet. However, the really science-rich sites are always at the cliffs, and these rovers cannot get there. So something like this will enable those kind of exploration in the science-rich sites on planetary surfaces. This is Scalar. Now, we talked about legs, but what about wheels? Of course we have robots with wheels. This is called Ombro, omnidirectional balancing unicycle robot. And as the name implies, it has one wheel. It's omnidirectional, can go forward, backward, sideways, and diagonal. But if you look at it, it doesn't even need to change its orientation. When you see it, it's almost like magic. It feels like it's gliding over the surface. Isn't that cool? It can also balance and climb very steep surfaces. Now, it follows paths. Now, yes, it has one wheel, but actually has these smaller rollers in the rim to generate this kind of motion as well. So why do we want to build a robot like this? We like to have robots living with us in this environment. And in this environment, sometimes there's crowded, a lot of people or obstacles. To go through people or to avoid obstacles, it's very important to have a very small cross-section. And probably a single wheel is the best way to have a very small cross-section. And this is Ombro. Now, I've shown you many different shapes, sizes, mechanism robots. And if you remember this, the whole thing started because we had problems with this bipedal locomotion. Is there a way to make these humanoid robots not fall at all? There is. And this robot is called Baloo. This is my son, Ethan, by the way. What if robots never fell? What if we could change the direction of gravity? I'm very excited to show you our new robot, Baloo, buoyancy-assisted lightweight leg unit. This robot is a bipedal robot, size of a human being, but the body is a helium balloon. It's a balloon with 2 legs. How does it walk? It walks like this. Very elegant, isn't it? This robot might be the safest robot out there. It can walk forward, backward, sideways, can turn directions. Yep. We want this robot to be living with us, so it can climb upstairs, downstairs, go over obstacles. It's fun to play with it. Play with. It can hop. Now it can hop up to the height of a tabletop. Oh, this robot is a good dancer. If you turn on the music, it listens to the beat and it dances to the beat. Now, we do crazy things when we do experiments. Once we opened the window and threw the robot out the window. Isn't it great? It solves all the problem of bipedal locomotion. It's cheap, it doesn't fall down. However, it also creates new problems. This robot is horrible outdoors because if the wind blows, it floats away. Now, these are some of the images of our secret projects. I'm not going to explain it, but we're using projection mapping, vortex scanners, and many different things. Oh, this robot literally can walk on water. You put ping pong balls on the foot, it can walk on water. It can also walk on a tightrope. Is this cool? This is Baloo. By the way, all of our videos end with a bang, like this. Isn't that cool? This is Baloo. Thank you. Now, all of this new inventions and creativity came from the problem of humanoid robots. However, secretly, we've still been working on humanoid robots. And this robot is called Artemis, our latest one, advanced robotics technology for enhanced movement and improved stability. And this is the very first time I'm showing to the general public. This is a sneak peek of what is about to come. Now, this robot Artemis uses new type of technology. It's based on that bear actuator. And because it's so new, you cannot buy any of these components. So we have to design and fabricate every single part of this robot. We have just finished assembly of the lower body. And I'm very excited to show you a sneak peek of robot Artemis. And Artemis is coming too. I cannot wait to show it to you, probably on stage in my next talk. I've shown you a lot of our newest creation robots from our lab, Romella. And I would like to give credit to our brilliant, hardworking students at Romella. But what is the source of this creativity? What's the source of this energy? What is the secret to this crazy productivity? I think the next video will be able to answer that question. Look at that. You remember Baloo? We're doing the experiment of dancing. By the way, this is Saturday, 2 a.m. in the morning. We're having too much fun, so yeah, let's bring out all our robots one by one. You remember Nabi? An early prototype of Alfred. Everybody's favorite Darwin OP. The rotating knee mechanism for Nabi. The 6-leg Hexapod robot. This is Romella, the Robotics and Mechanism Laboratory at UCLA. By the way, that's me on the left, dancing. You probably haven't seen a professor dance and party with their students while conducting serious experiments, right? Openness, freedom, trust, having fun, and truly believing what you do can change the world. These are some of the secrets behind our next 7 species of robot. Thank you very much.